Hey everyone, it's Sean. Welcome back to the channel. I have a SounDigital 3000.1 Delta I believe EvoX2 car sub amplifier. It might be labeled somewhere on the board over here.
Okay, this is Sean from the future. Just want to pause everything and say this is a no fix video. Regardless, I think there's a lot of good troubleshooting that you can find if watching this. So just sit back and enjoy it for what it is.
But anyways, when powered on and these in here, we have a flashing yellow light sitting right here. Okay, and that usually indicates that there's a short or low resistance to the speaker output, and so something is bad along that path. So I've pulled out these boards and tested our components on here, our MOSFETs here and here, and everything seems to be okay via multimeter test. But maybe there's still an issue I'm just not detecting with a multimeter. And I know somebody's going to say, well, check it with an O-scope. Maybe I'll do that, maybe I won't. But what I think I'm going to do out of habit for this one is just go ahead and replace. Now they scrub the part number off of these MOSFETs here. You can see on the board the IC in the center is a IRS 2052M. So these are going to be power MOSFETs here. Probably around 150 volt, maybe. We'll find out. I'll have to do some research. And then IRS 7440. Of course, we have those two double diodes, the 1620RG and the 1620G. That's, creating rectification. They're good. I checked all the resistors. They seem to be good as well. Like I said, what I think I'm going to do is replace these components regardless and solder it back in and test and see if we still get it a flashing yellow light. And then if not, then probably power up from that point and see what we get.
Now, to kind of go about to show you how I would test these MOSFETs, well, the board here, I'm going to take my red probe to this inner pad here first, and I'm going to go ahead and test this first MOSFET on the outside. All right, 0.6 voltage drop. Next three pads are a I wasn't touching it. There we go. Small little legs. First pad, voltage drop, diode. Short, short. There we go. Short, on and out. Very tiny legs. So that's going to be the source, and the gate of here. So this side should be the drain. Again, keeping red probe right here on this pad. Drain should all read like a voltage drop. Okay, like a diode, and all four of those pins do. Now I'm going to move my probe, red probe, over to this center pad. Adjusted. Let's see. So again, source, gate, and then drain should be on this side. All right, and that appears to read fine. All right, so going from this pad now, let me check. This IC, drain appears to be good. Source is on top, so that means gate's at the bottom. Yeah. All right, now moving to this pad. Drain, source, get on top, and then gate. So these are measuring okay as far as a static test with a multimeter. Okay, keep that in mind. Let's check these MOSFETs here. Let's see, give me 1 second. For these, and these MOSFETs are almost obsolete. I think stock is running out on them. I'm going to take my red probe to the drain of the MOSFET. That's this center pin right here. Okay. And then I'm going to check at the gate. Then no connectivity. So now let me check at the source. All right, no connectivity. Now let me reverse them. This lead. All right. Notice how that's a 1.6 voltage drop. Let me short out the gate and the source with my finger for a second. Now notice that's 4.471 voltage drop now. And when I touch the red probe to that other lead and then back again, it's back to 1.65. All right, so this is how I would test all these. I'd make sure we've got no conductivity with red probe on the drain, and then test it between the gate and the source. But when I go between the black probe on my drain, I check source. I should see, well, let me short it out first. There we go. Should see about 0.471. Then when I at the source, but then when I tap the gate, that should cause the MOSFET to switch. And now I got a voltage drop of 0.166. So I would test all these in this fashion. And to be honest with you, I have, and they are testing good. But again, this is a static test. Okay. So let me first talk about parts. All right. The MOSFETs we have sitting here, the part number IRFR7440. Lift this up a little bit for you. Hopefully you've captured that. All right. Let's see. 40 volt, 90 amp, 2.5 mega ohm, 89. What did NC stand for again? Nanocoulomb or something? I can't remember. Anyhow, these are going obsolete. There is a substitute you can get for these. So even though this one part number is going obsolete, you can get parts for it. Okay. And then these right here, as I mentioned, these in-channel MOSFETs, the part number scrubbed off. Hey, here's your part number, what to replace them with. You see it right there. If that is focusing. There we go. But you can see 150 volt, 220 mega ohm. Okay. These are still readily available. Now, why do I say they're tested good with static testing? Well, it's to kind of allude to you that, hey, static testing is not the same thing as testing a device under operation. You see, with MOSFETs, when we're testing with a multimeter, okay, static testing, you're testing for basic shorts, circuits or open circuits. It's not really a full characterization of the MOSFET behavior under all operating conditions. So, you know, there could still be gate leakage that would not be seen by the multimeter. And gate leakage could still, cause a MOSFET to behave erratically. There could be unwanted conduction even when the gate voltage is off, causing problems like increased power consumption or instability. The multimeter itself could be too sensitive or not sensitive enough to detect very low levels of gate leakage. Those kinds of things, okay? But what I want to do first is I want to switch out all the MOSFETs on here, solder in replacements, and then test it to see if it will power up at that with no flashing yellow. And if it doesn't, then I'm going to do this IC here. So that's what I'm going to do. I'm going to go off camera, replace these MOSFETs, and then when we come back, we'll do a little bit of testing. Well, I've got it back together, and we'll go with here. We will, whatever. Go with the first power up test, since replacing those MOSFETs. If they were the issue, I should see this power on LED go blue and stay blue. If they were not the issue, then we're back to flashing yellow. Let's see how it goes. I've got 12 volts set up by my bench top power supply, and I'll feed in 9 volts. Hey, we got no, we still got an issue. Well, it wanted to. It definitely wanted to. Okay. So, looks like we're still got some more troubleshooting to do. Before I jump to that IC, the driver IC, I'm going to take a look at a few other things. And then I'll let you know what I discover when I come back. Well, I've tested every cap in here. They all seem to be good. Maybe the driver IC is bad on here. And so that's pretty much the last thing, or one of the last things that we can check. And to check it, really the only thing I can do is remove this board back out right here, and then replace that driver IC with this part number we've got right here. What is this? IRS 2052. We'll replace it with that guy. So I think that's what we'll do next. I'll replace the that driver IC or audio amp IC, whichever it wants to be called, and we'll see if that rectifies our issue. Well, I hate to admit it, but I spend too much time on that IC than what I care to. Usually when I'm soldering on an IC such as this on the board, I like to spend as minimum amount of dwell time as I can applying heat to an IC, especially when reflowing, to ensure it's on the board. And sometimes I'm able to let it cool down and put pressure on the IC top to hold it in place, but that one was just so tiny it just kept slipping. So after the second time of doing that, or third time, I was like, okay, I just need to stop, reflow it, let it go down, cool off, and then I'll use the the hook tip on my soldering iron to just kind of go across as best as possible to hopefully heat up any termination points between pad on IC and pad on the board, and make sure that they're nice and flowed. So one of two things can happen now that I got plugged in. It could be worse, it could be better, or actually a third thing, it could probably be the same if I burn out the IC. We'll find out. Anyway, so I'm going to go ahead and turn on my benchtop power supply. We'll get 12 volts into the board. And so 12 volts is there. Now with my signal generator, I have it set to produce a DC signal. I'm going to turn on the output, and let's increase it. And unfortunately, we're going right to flashing. So it's either the IC, I didn't flow it good enough, or yeah, we still have the same issue and I haven't resolved that issue.
Only other thing I can think of that could be causing this issue is possibly one of these two ICs here. You have a LM319 IC sitting here by ST Microelectronics, just an IC comparator circuit. So you're going to have audio coming into this and being inverted. This is going to have a little bit to do with how we're Class D amplification, how we're converting the analog audio and essentially chopping it up. I guess that's the best way for me to put it. Maybe not as accurate for me to put it that way. But you also have, since this is a, 1-2 inputs? Yeah. Left and right channel only. Yeah. For an output. And then you also have a TL074CN by Texas Instruments. This is an OpAmp. Okay, so that could be also what's creating the noise. I would assume this before the comparator, but they're both easy to replace. They're both, let's see, 1, 2, 3, 4, 5, 6, 7, so 14 pin ICs that can easily be swapped around. I went ahead and just ordered our TL074DT quad low noise JFET and our LM319 Delta Tango high speed dual voltage comparator. Okay. And you know what? I figure for the sake of the video, this has been exploratory for myself, kind of working at the end and coming to the front end to find this issue. And most of you all who watch these videos, if you've ever worked on a car amp, you're probably yelling in your screen right now. So you should have just gone to the ICs up front first, blah, 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 blah. Again, I'm just trying to be thorough documentation. Maybe this will help out somebody else instead of just jumping directly to where I would suppose some things are broken at and just filming that piece. I don't think that does the community a whole lot of service. So that's why a lot of my videos are a little bit longer than probably what they should be. And there are people who like it and people who don't. Well, I've replaced it, powered it up. And as you can see, flashing light, still the same thing. Check the DC and AC measurements. They're about pretty much the same. O-scope measurement, pretty much the same. Meaning within like 0.1 of what the previous results were, or less. So I guess You know, I highly doubt LM319, but we'll replace that as well. At least we can say we replace the comparator and the OpAmp. Got that IC replaced, powering it up. And unfortunately, it's in lockdown again. Let's come back to this SounDigital 3000.1 for a second. I've kind of mothballed it, given other amps I needed to work on, and all the parts I replaced, not bringing it back to life. I just need to gather some time to think and do more troubleshooting and just see, you know, come to a consensus, I guess, is what I'm trying to say. But here goes the microcontroller on it. Okay, and these microcontrollers have to be programmed. So unless if I was a vendor or a repair technician being paid by SounDigital with the gear in order to do the programming, that one is that one's a bust. I won't be able to do anything with that. I've tried reflowing it. No change there, which could also have an impact as to why we're constantly getting a flashing light on it, because well, in all honesty, when I'm measuring here at the bottom, take off some leads for a second. When I'm measuring here at the output, of course, I got the board removed right now. I was in things out, and I'll put the board back in a minute. That in and enable pin at the board, I'm not getting anything there. Okay, I get 15. I got IN1 and IN2, but enable, I'm not getting. And if you trace out that pin, eventually it's going to come all the way from the right side of the board over here to the left, and you'll see it show up right here at down here at that 100 ohm resistor sitting right there. Right there at the 10K resistor. Then that feeds through that diode A215, which measures fine, and so is the resistor. Yeah, trace it around. It comes into this diode right here. Those diodes, 60 and 6M are in parallel. Both of those check fine with a digital multimeter. And then I follow this trace up, and you can see obviously it goes into here. Okay, so we're not getting the enable from the microcontroller. All right, we got an LDO sitting over here where at that top left pin is 12 volts, center pin ground. Bottom left pin I see 1.2 volts, and the two pins over on the right tied together show 5 volts. So I believe that LDO is fine, which would be supplying part of this entire circuitry over here. Anyways, I also see 5 volts on this 5 volt pin. Ground is there on SPD0. I've got 5 volts there, so that's good. But I've got nothing on clock, which is derived from the microcontroller. So I have no clock. I have no enable either. Then we've got a basically a 2EDN7524G. Basically a MOSFET, and 10 volts on ENA, that's pin 1 there in the bottom right, 0 volts on INA on pin 2, 0 volts on ground, pin 3, top, second from the top on the right, very top right, INB, that's in 0 volts there. On the left side, top left, out B, 0, VDD, right beneath it, I see 12. Right below that is out A, I see 0 volts, and then enable, I see 0 volts. Okay, so most likely, so this needs to be enabled from the microcontroller as well. So most likely, that's not driving. I mean, I can try to replace it, but I highly doubt it's that. But most likely that is not turning on because this microcontroller is bad. So I'm going to do 2 things and call it a day. Most likely this microcontroller is bad and we're not going to be able to fix it. I'm going to attempt to replace that MOSFET there just for
hoops and giggles. I'm gonna get it replaced, and then I'm gonna get the digital audio board back into this, the amplifier board, and we'll power it up one last time once I've got all that done. And if it's no go, it's no go, and it's just time to call it a day. All right, with the amplifier board back in with a known good driver IC, we'll now check that enable pin one more time using DC, and I get 3.8 volts DC on that enable pin with the board in. So at least now we have enable again, although I don't think it's high enough. I think it's got to be a little bit higher than that to actually drive the output here. Obviously I have everything on. It's only pulling 0.2 amps, but with my O-scope and 1x, I'm going DC couple, or excuse me, go from DC coupling to AC coupling. Okay, and we just want to measure the clock. That's going to be this little small pin down here, and you can see we're still not getting a clock whatsoever. So now imagine it would be around 1 volt, some kind of sine wave or something, but it's just that there's nothing there, absolutely nothing there. Even if I put this lead to ground, you can see, yeah, we've got nothing. So if it's not producing a clock, that's that's going to be the MCU, the microcontroller, and I'm just going to call it what it is. If anybody else has worked on these and knows anything different, you let me know what you think it is in the description. As far as I'm concerned, I think I've pretty much proven, after replacing all the components on the driver, switch mode, power supply, capacitors in this thing, checking all the output capacitors. I mean, really going over so many things, diodes and transistors and all of them looking good. Getting over to these pins here, back tracing the enable pin to the microcontroller with this removed, not having the enable voltage over here, just simply not getting a clock. I think I've pretty much proven that the microcontroller for this one is the issue. So that being said, well, this one's a bust, but if this video has helped anybody troubleshoot an issue down to the same things that I've looked at, then let me know in the description. Unfortunately, I'm gonna call this one quits, and that's it. Thank you for watching. If you've enjoyed my content, let me know by leaving a comment in the description. If you're new to this channel, consider subscribing. You're already here, you might as well, so hit that subscribe button. And yeah, take care and goodbye.
Bart?